Have you ever been woken up by a chorus of birds at sunrise and wondered, why do they all start singing at the same time? It's almost like they're performing a grand morning concert. But what's the science behind that? We're diving into the mystery of the dawn chorus, and Dustin's here to break it all down for us.
Next, we're tackling one of nature's most incredible feats, migration. Every year, millions of animals, birds, sea turtles, whales, and even butterflies embark on journeys that simply defy logic. How do they do it? We'll explore how animals use Earth's magnetic field to navigate these epic migrations.
And finally, as we're moving into early spring, we're asking, how do animals know when to wake up from hibernation? From bears to groundhogs to even some surprising hibernators you might not know, we're going to uncover the science behind their seasonal wake-up calls. So grab a cup of something cozy, sit back, and let's dive into this week's topics on Nature Notes with Hike Hearth. So I don't know about those of you watching, but I for sure know that there have been more days than I can count when I've been woken up by a chorus of birds singing their little hearts out at sunrise. And I've always wondered, why do they all start singing at the same time? It's almost like they're performing some kind of morning jam session, right? But what's the science behind that? Today, we're going to dive into that mystery of the dawn chorus and why birds sing at dawn and what it really means. And of course, to help us out with this, we have my husband, resident bird stud and birder, Dustin here. Dustin, before we get into why birds even sing at dawn, can you explain what the dawn chorus actually is and which birds participate in it? Because it's not all birds, right?
That's right. So the dawn chorus is a period of intense bird singing, a cacophony, if you will, that occurs just before to just after sunrise, roughly an hour before to an hour after, but it can continue several hours later depending on the time of year as well. And you're right, not all birds sing in the dawn chorus. Mainly it's songbirds like robins, which are in the thrush family, the other thrushes, warblers, and sparrows. Some species, like the European robin, even sing if there's artificial light nearby.
Why do birds sing so much in particular at dawn? Is it just because they've just woken up, so they've got lots of energy? Like our dogs are like fired up and super rambunctious in the mornings because they've got all this energy they've been building all night while they've been sleeping. Is that what's going on?
There's some of that, but the early bird theory applies here. And there's advantages to being first. So one of the main reasons birds sing at dawn is to defend their territory. At this time of day, the air is cooler and calmer, making the sound of their song travel farther, and it's simply the perfect time to announce ownership of the area before anyone else does. Studies have shown that birds who sing more consistently at dawn are also better at holding on to that territory. And if you hold on to a territory, it means you might be more successful with the ladies.
Ah, I see.
So for male birds, singing at dawn is about impressing the female. So a strong, complex song signals to a female that he's healthy and has good genes. Some studies suggest that females prefer males who start singing earlier because it shows their stamina and their experience, which are key success factors to breeding for birds.
I have to say, as a human lady, I'm glad you didn't take that approach to wooing me back in the day, because having you singing your little heart out at 5 a.m., I don't know if that would have done it.
Well, it's never too late. But birds wake up cold and hungry after a long night. Singing helps them warm up their muscles, get acclimated to the day before they get out searching for food. And oftentimes you see birds what's called tree topping, sitting up on the very tippity topmost branch of a tree, just singing their heart out. And I wonder if they're up there just so that they can project as far as possible, or maybe they're trying to get up into the sunlight and absorb those first early morning rays to warm themselves up.
Maybe they're just practicing for American Idol. I don't know. Okay, so this all makes sense. But how do they know to start singing at that time of day? Is it just because the sun's coming up? Like What kind of triggers it?
It's a good question because some places where birds are up and singing, it's essentially daylight all day long up in the Arctic. So it's not just
Oh.
the changing of the light. Birds have internal clocks or circadian rhythms, just like humans do, and they're influenced by light. So at dawn, even small increases in the light levels, even if it wasn't dark at night, the increase is something that they do key off of, and it signals their brains it's time to sing. And they have a hormone called melatonin that regulates their sleep, similar to people, and decreases at dawn, which helps birds wake up and they get started vocalizing.
I have melatonin on my nightstand right now. Okay. All right. So
Did they hope they didn't squeeze it out of birds?
very funny. That's awful. Why would you say that? What kind of bird are you? Anyways, all right. So you've got birds that sing at dawn. Not all of them, but some of them. But when we started this discussion, I asked you to kind of confirm that not all birds do this, and you said that's correct. So what about are there birds that sing at night?
There are. So some of them have it in their name, like nightingales, and mockingbirds are notorious for singing at night, especially in urban areas or places where artificial light is present all night long. That can kind of confuse their internal clocks a little bit. And owls, of course, are made to live and be active during the night. So they call all night, also about territory and communication. And lots of birds also migrate at night. So although it might not technically be their singing, their flight calls while they're migrating overhead during the night can be used by advanced birders to even identify the species that are passing overhead during the migration season. But we'll talk about that later.
Why do you think birds evolved to sing at dawn in the first place? Do you have any theories on that?
Singing is their dating app.
Yeah, but I mean, how many people are using their dating app at 5 o'clock in the morning? Actually, I shouldn't ask. Like, I don't know. I know nothing about dating apps. So,
Me either. It's all about improving their access, their odds, and their success with a mate. So singing at dawn likely evolved because it's a time when predators are less active, giving birds a safer way to communicate. And it's a time when females might also be just waking up, and it's a good way to get their attention even from afar. And females are sort of more receptive to mating calls at this time, so it makes it a strategic time for them to sing. And interestingly, some studies into birdsong during the COVID era showed that when human activity was greatly reduced while we were all staying home, particularly in those first 2 weeks of lockdown, the ambient noise in the environment was reduced, and birds actually started to sing more away from dawn when there was less noise pollution and competition. So partly it might just be that they're singing at dawn because it's quiet and it's the quietest time and therefore the most effective for them.
so they have to get up so early because of us. It's our fault.
In urban environments and even some suburban environments, sure, but there's lots of places where they're not impacted by that. But it does go to show that noise pollution isn't just something to annoy your neighbor.
That's kind of a bummer. I feel a little guilty about that, but okay. So now we understand what the dawn chorus is and kind of why it happens. It seems pretty straightforward. Is that all there is to that story? Are there any other amazing, like, fun facts that you want to drop on us in this episode about the dawn
I
chorus?
could do this for a week.
I know.
No, but interestingly, birds of the same species don't all sound alike. They have accents and regional dialects just like people do. So a robin in New York might sound slightly different than an American robin in California. And song sparrows are particularly regional in that way. So just because you hear what kind of sounds like a song sparrow, if you're not in a place where you're from, it might be the song sparrow you're used to, just sounding differently. Young birds learn their songs by listening to other adults, and dawn is the best time to practice because there's less background noise and they can hear the other males of their species singing clearly. So it's a good time to learn also. And if a young bird doesn't learn its song during this period, it may not develop a proper song. And that might mean that it doesn't develop it this year and has a whole year of practice so that it has a chance at breeding.
I thought you were going to
Next
say
year.
that means it turns into a rap artist. Not that rap isn't a proper song. I like rap, but like Or they become beatboxers or whatever.
So birds start singing earlier on clear mornings than on cloudy days because light levels play a big role in triggering them to start their songs. And like mockingbirds and starlings, even some thrushes can mimic other bird songs and sometimes even car alarms or human sounds. So there's really a strong instinct for them to learn the songs around them so that they can defend that territory. And sometimes they get fooled into defending another bird's territory or kind of mimicking all the other birds so that all the other birds avoid that territory, leaving it just for them. What I think is super interesting, maybe it's a little dorky, but birds can even hear at different speeds than humans do. So if you're familiar with the song of a wood thrush or a hermit thrush, it kind of comes in three parts and it sounds like really fast and high pitched and stuff. But we know birds actually hear that in a much slower, more precise manner. And those notes embedded in the tune that we can't really even break out, they're hearing almost in slow motion. And so the fidelity of their song is really precise for those species.
That's amazing. I wonder what our music sounds like to them.
I don't know.
Because it must sound different to them if they have that capability, right?
Yeah, I think animals just experience the world in different ways. Just
Huh.
like you see a bird flit into the bushes and you think their eyesight must be super keen to be able to go back and forth really quickly, their hearing has the same kind of agility.
That's really neat. Okay, so to recap, birds sing at dawn. It's mainly to defend their territories and attract their mates, and maybe to warm up for the day a little bit. And what else? Like they pick that time of day because the air is calm, it's a little more quiet, their song can carry a little bit farther. There's less competition from all the noisy humans in the world. And that's kind of why they've decided that's a perfect time of day to communicate. Okay. I wonder from our viewers, what do you notice about the dawn chorus where you live? Are there particular birds that you feel are competing better with their song in the early morning than others? I can tell you I hear those blue jays for sure. And yeah, what birds do you hear the most in your areas and which ones are your favorite? Mine is the mourning dove. Do you have a favorite?
Well, cardinals are on my mind because it's early March here, but well, it's early March everywhere, but it's early March at the moment. About 2 weeks ago, on February 22nd, I noticed the sound of cardinals singing for the first time, and it was it felt like opening the curtain to spring. You heard that first mating call of any bird. So, do you have any species that you've been noticing lately or that you associate with the dawn chorus? Let us know. And for those of you watching, if you have any questions that you'd like us to address in our Question of the Week series in the future, drop them in the comments and be sure to subscribe and turn on notifications so you know when we've researched your upcoming discussion topic.
So every year, millions of animals, birds, sea turtles, whales, even butterflies, embark on migrations that sometimes can seem to defy logic. And some of these animals are even returning to the exact place where they were born. And they're doing that without a map or GPS or a smartphone, or sometimes even any prior experience of being in that location. So, Dustin, let me ask you, do you have any ideas on how exactly they're doing this?
Well, different animals have different strategies, right? We'll talk about some of those. But migration is the seasonal movement of animals from one region to another, usually for breeding, feeding, or avoiding the weather. Animals face predators, storms, and human made obstacles like cities and pollution, so navigating accurately is critical for their survival. But those risks are very different, or can be very different for different species. Birds, for example, are making a critical judgment to gamble their lives to migrate in hopes of better food, habitat, or breeding success. It's like a Sophie's choice for them. But instinctually, they know that it's better for them over the winter to survive down south, and it's better for them to raise their babies up north in the northern hemisphere, because the food situation is much better for them with the way that bugs and larvae are plentiful in the north. But it's not just birds that migrate, it's sea turtles. They migrate. Their biggest risk is temperature. Whales, monarch butterflies, and salmon migrate. Plus, there's short distance migrants, like we talked about last week, in salamanders and frogs and toads and things like that. They're moving to new areas to reproduce. And in Africa, it's often about the seasonal weather patterns that produce drought and then eliminate it, that forces the animals into seasonal migration so that they can literally get a drink of water. And so, how do they do it? A lot of animals use Earth's magnetic field to navigate. Some species rely on their generational memories of their elders, like the whooping cranes we've talked about recently. And this is true for some African savanna species as well, because with changing weather patterns, they rely on their elders to make the critical decision to follow known migration routes or to search for alternatives at their whole group's peril.
Okay. So you mentioned magnetic fields, and that's probably going to be the focus primarily of today's topic. And I remember from school as a kid that, at the Earth's core, there's this molten iron core, right? And that is really where our magnetic field on Earth is generated from. And it creates these like invisible lines of force that run from that magnetic core. And so that we've got magnetic North Pole and we've got the magnetic South Pole, right? So we know this exists. We have magnets. We're aware of it. But like, how animals aren't walking around with their little pockets full of magnets or a compass or whatever. So how do they detect it?
No, but just like a compass needle aligns with those lines, some animals have biological mechanisms that allow them to tap into the magnetic fields as a sixth sense almost for navigation purposes. Some animals have cells containing magnetite, which is a magnetic mineral that responds to these magnetic fields. Birds tend to have it in their beaks and in their brains, while sea turtles have it in their heads. And it works like a built-in compass, helping them to orient themselves accordingly. When that malfunctions, however, it's believed that that might be why certain birds end up lost well outside their normal routine migration, such as when rufous hummingbirds from the western part of the US accidentally fly all the way east before they fly south, and we end up late in the season with some hummingbirds that simply don't live here any other time of year. So it's really important for them to keep things in working order. And while that magnetic field is crucial, animals can also use the sun, stars, and even landmarks to navigate. It's a multi-sensory system. And by landmarks, it might be something as big as a mountain, could be the ocean, the coastline, the Mississippi River. So it is more dynamic than just magnetic fields.
Okay. All right. So they're attracted to the magnetic field or something like that, right? But I guess I don't entirely understand how they use it. Like how are they like what's happening?
Yeah, we don't know exactly if they're attracted to it so much as they can sense it and they know where they're supposed to go or where feels like the right place for them as sort of an instinct. So birds like the Arctic tern, which migrates from the Arctic all the way to the Antarctic and back, use it to stay on course. So research has actually shown they can detect both the intensity of the magnetic fields as well as the inclination of them, which helps them to determine sort of the latitude and longitude that they're at, so they know where they're headed, but they also have a sense of kind of when they've arrived from that. Sea turtles hatch on beaches and immediately use magnetic fields to head toward the water. And as adults, they return to those same beaches to lay eggs, guided by the unique magnetic signature of that particular place on the surface of the Earth. Monarch butterflies are really different. They migrate thousands of miles from North America to Mexico, but they use a combination of the sun and magnetic fields to navigate. Other animals like whales, humpbacks particularly, use magnetic fields during their long migrations. It's believed that they follow kind of magnetic hotspots in the ocean that are mapped out by natural variations in Earth's fields. So over time, it seems like they've learned where the good food sources are relative to these known magnetic hotspots. And so they use that to inform their travel. And then strandings can even occur in areas where magnetic anomalies have confused that navigation.
Okay. Um, all right, I think I get it. So you mentioned sometimes there's a confusion with or an anomaly, right? So and you mentioned what happens to whales. So obviously disruption to magnetic fields happens, or else you wouldn't have given an example of how whales experience that. And you mentioned that hummingbirds sometimes get lost. What are like some of the causes of these anomalies though? Like how does that happen?
Sure, sometimes there's a causal factor that's maybe brought on by humans, but sometimes it's an internal malfunction for some reason as well. So it
Okay.
could happen, think of it both externally to the animal and internally to the animal. But for example, human activity like underwater cables in the ocean, power lines overhead, those can create anomalies that confuse animals. And large underwater cables can sort of create different electromagnetic noise that can confuse fish and sea turtles. City lights can do this, particularly to confuse birds that are navigating by light, both celestial and magnetic cues. And whales can even beach themselves in areas where a magnetic field is weaker. Some studies show that they get disoriented and sort of swim in the wrong direction. That's how, particularly when the tides go out, they can find themselves disoriented in these shallow zones that can be harmful for them. And homing pigeons are a really uh, familiar example to people, about being, really experts at guiding themselves back to their home roost. But they can have trouble navigating near power lines because of that electromagnetic interference.
So they're sensing the magnetic fields in some way, right? Like do we know how? Do they feel it? Do they see it? Like do we know what their experience is or not really?
Uh, we have some understanding of it. We don't know what it feels like, but the sense is sort of called magnetoreception. And this is the ability to detect magnetic fields. And different animals, we believe, can sense it slightly differently. Birds like robins and warblers, it's linked to a protein called cryptochrome that is in their eyes. And so researchers think this allows them to kind of see the magnetic field as like a visual pattern, or maybe like a faint blue sheen. And if they can kind of go toward the blue, they're heading in the right direction, so to speak. Experiments with robins in controlled environments around magnetic fields have shown that they can adjust this orientation based on changes in those fields. Some aquatic animals like sharks and rays have highly sensitive electroreceptors kind of in their snout that allow them to sense the magnetic fields in the water. Sharks in particular are very sensitive to this. And they have some amazing migration patterns that are really only just coming into focus because of modern like radio tagging and stuff like that. We see like the Great White Shark Conservancy and those programs have really finally unveiled what those migration patterns look like. But back to the Arctic terns, they can sense both the strength and the angle of a magnetic field. So think of it like a GPS that gives you your latitude and your longitude point. It helps them literally know where they are on kind of the grid of the whole planet.
That's so wild. Okay, so what about other animals? Like, do mammals have the ability to see or sense magnetic fields?
Some of them do. We don't know exactly how, but cows and deer are both known to align their bodies north-south when they're grazing.
Really?
Yeah.
That's interesting.
And we didn't plan this either, but dogs are known to kind of always face in the same direction when they're pooping. Now, I don't know if that's because of magnetic stuff or the sun orientation, but there's a chance that dogs do it naturally too for unknown reasons.
That's crazy. I thought they were just looking for some privacy.
No, I don't know. But bats are another one that have a great magnetic sense. This helps them navigate. And there's been some experiments. I recall an NPR story from a number of years back that highlighted how they took big brown bats from a known roost in a barn and they put them in like big glass jars and exposed them to some magnetic field disruptor technologies. And then they drove them like 20 miles away or they tagged them before they put them in the jar and they drove them away to see if the bats who are known to always go back to their same roost every morning, if they were able to immediately go back to their roost or if they were going to get lost or what happened. And it basically turned out that they all wandered kind of aimlessly, like they couldn't find their way for several hours, but they eventually just kind of shook it off and their instruments got aligned again and they headed back. Most of them within a few hours. Some of them took until the following day, but they pretty much all returned back to the roost. So it was proven that the magnetic disruption impaired their navigation abilities, but that it was temporary.
I don't know that I would like if somebody put me in a jar and like drove me out in the middle of the woods and was like, all right, go find your house. But okay.
Right. Good thing you have GPS then.
Yeah, a good thing I have a smartphone. All right. So I'm assuming humans don't have this ability. I mean, I can verify that I am a human. And I know I can't sense a magnetic field, or at least I've never had that experience. So we're off the list, right?
Yeah, there's no proof that people have this sense, although I certainly have known some people that have just a very innate sense of north-south, and you can sort of say to them like, hey, turn west, and they know which direction it is. I'm certainly not one of those people. So is it nature or nurture? I don't know. So some scientists expect we might have some remnants of this kind of magnetoreception in our DNA, but there's no like clear evidence of that.
I wonder for the scientists who think that there's like some residue of that in our DNA. I wonder if we just evolved away from that as our species became less and less nomadic over evolutionary history.
Could be.
Because we might have needed it at one point until we got into actual agriculture and we stopped wandering around all over. But I don't know that we ever, like historically, even like way back at the dawn of time, like migrated because of weather. I don't know. Okay. I will say, like, I'm really amazed that animals even like have this ability to like not only travel the crazy distances that they do, but to get exactly where they need to go when they don't have any of these tools that we have. I mean, I can't even navigate a couple 100 miles without a map of some kind and information to kind of get me there. So it's crazy.
Yeah, humans had to resort to tactics like numbering the interstate highway system so that the numbers tell you which direction you're going.
Yeah, exactly. All right. So, in asking you to help me research this topic on migration and magnetic fields and stuff, did you end up developing any fun migration facts that you want to share with us?
I'm going to go back to the Arctic tern for this because today's low-key my favorite day of the year because we're turning our clocks forward tonight.
Oh, it's my worst day. I hate it.
Well, tomorrow's my favorite day of the year because we finally have time after dinner or after work to walk the dogs in the daylight. And the reason I'm tying this to the Arctic terns is because they migrate all the way from pole to pole. In the summer, they experience 24 hours of daylight. And then in the middle of the year, they have a normal day-night, but then they migrate, as they're migrating down south, they hit the South Pole, and now they have 24 hours of sunlight during the winter. So more than any other species on the planet, probably, they get to experience daylight the most.
That's a cool trivia fact.
Yeah.
Anything else that you want to cover on migration?
Just how interesting the migration of the monarch butterfly is, because this is not a little insect that just knows its way down to Mexico from North America. It's actually a multi-generational and multi kind of life cycle migration pattern for them. So the migrates that migrate to Mexico in the fall are not the same individuals that return north in the spring. It takes monarch butterflies 3 or 4 generations to complete a full migration cycle. So the ones that leave Mexico in the spring fly north, lay eggs, and die. Their offspring continue that journey northward, repeating the process until the final generation emerges in late summer or early fall. And that final generation, known as the super generation, lives much longer, up to 8 months, and they make the entire journey back to Mexico, even though they had never been there before. Scientists think monarchs use a combination of the sun's position and Earth's magnetic fields to navigate. They also seem to inherit kind of a genetic map that guides them to the same overwintering sites in Mexico. These sites are where a fir tree called the oyamel fir tree is located, and these act like a natural umbrella for monarch butterflies, protecting them from rain and extreme temperatures. The butterflies then cluster together in huge numbers around these trees, sometimes covering the whole trees, and helps them to conserve heat together. And the fact that monarchs can find these specific trees despite having never been there suggests an incredible innate ability simply encoded in their DNA.
For me, I think today's discussion was really a reminder that there's still so much to discover about the animals that we share the planet with. You had touched on some research, but you had also said that there's certain things that we still don't know about how animals figure out how to migrate, and scientists are still hard at work doing that research. I think it's exciting that there's still new things about our planet and the animals that live on it to discover, for sure.
Definitely. So I'd be curious to know from those watching, right? What animal migration fact blew your mind the most? And what animals do you witness migrating in your area? Let us know in the comments, and be sure to subscribe and turn on notifications so you know when we put out more videos just like this.
So, as we move into early spring, I've been wondering, how do animals know when to wake up from hibernation? We know that there's some animals that have been hibernating through the winter, but it's not like they've got a smartphone or an alarm clock in their little burrows and caves that is going to ring in the next couple of weeks. So today we are diving into, in our Nature Curiosities series, the fascinating science of how animals instinctively time their emergence from hibernation. So Dustin, let's start with the basics. Would you mind laying a little bit of a foundation for us on why some animals hibernate in the first place?
Sure. So hibernation is a physiological state, a transformation that an animal's body goes through that's all about conserving energy during times when food is scarce, or simply the equation of calories intake and calories expended doesn't balance in a way that can support their survival effectively. So usually that happens in winter, when it would require a lot more energy to stay warm and stay alive at a time when food is scarce. So certain animals can slow down their metabolism, their heart rate, and even their body temperature to survive long periods without eating. We often think of bears, they're kind of the classical example, but hibernation isn't just for them. Other animals like groundhogs, bats, and even some rodents hibernate or go into kind of a half hibernation state called torpor as well. Fun fact, certain frogs, like wood frogs, can freeze solid and survive by producing a natural antifreeze in their blood. We covered this in a previous episode, so check out episode 10 if you want more details about that.
Yeah, that was actually a really fun discussion, and we discussed Big Night as well. And if you don't know what that is, I also recommend checking out that episode. But okay, so winter came, they all went to sleep in their little burrows. I kind of envy them. I kind of like to hibernate a little myself and stay inside in front of the fireplace in the winter months. But what wakes them up? Like, is it just that the weather gets warm? Like, is that it? They're just like, oh yeah, it's not cold anymore, I might as well get up.
Primarily, but there's two major triggers. One is rising temperatures, and also increased daylight or photoperiod, the sort of number of hours of daylight, are both big factors. So animals can sense this change in the seasons and respond accordingly. Even animals hibernating underground in caves like bats can detect subtle temperatures and humidity changes. The humidity changes are important, particularly in cold climates, because when everything's frozen, there's not as much humidity in the air.
It's
so
really
they can
dry.
sense it that way. And then some of them simply rely on their biological clocks. So groundhogs respond to changes in the length of day. Bears wake up as their fat stores turn low. So there's biological processes that play a role. And even simple things like needing to use the bathroom, which we think of that as something that happens every several hours. But if you're hibernating and you're not eating, you don't really have to process food and stuff much. So they might not have the urge to go to the bathroom strongly enough until several months have passed and it's time to actually come out of hibernating. And they might just get the feeling of being hungry, and the sort of hormonal trigger, giving them the sense that it's time to seek out a mate.
Okay. All right. It's funny. I now have this picture in my head. I get weird pictures in my head of like a black bear with like his little legs crossed, like trying to shuffle to the bathroom really quickly because he hasn't gone to the bathroom in 5 months. I don't know, something crazy, but I know that's not true. But anyways, all right. So getting serious.
I wish I had a good porta potty joke about bears. Need some help on that one.
I know this would have been a perfect time. Yeah, if you have some potty humor jokes about bears, feel free to drop them in the comments.
We know they poop in the woods already.
Yeah,
that's it.
When a bear wakes up, is it like, let's use a bear as an example since we're already talking about it. Actually, no, let's talk about animals in general. When an animal wakes up from hibernation, is it like instant, like, or is it like our teenager where you see her slowly kind of melting down the stairs and into the kitchen and it's like groggy, slow motion?
It's much slower than that. So it's not at all like flipping a switch. Waking up or coming out of a hibernation state requires all the different systems in your body to kind of kick it into another gear, and they might be out of shape, they might not have flex, they might not be hydrated optimally to be able to get back into action. So usually the first thing that starts is an increase in the heart rate, the body temperature starts to come up, and their metabolism starts to kick back into gear. Bears wake up sluggishly, and it might take them several days, even just sort of staying in their den and lounging around for a few days before venturing out because they need all their systems to come back up to speed. Smaller hibernators like ground squirrels, they can warm up much faster, but they need to find food right away. Bears tend to look for water and hydrate first because that's really important to getting their systems going. And then any like unexercised digestive tract also takes some time to warm up. So some animals aren't hungry right away, just as someone who's experienced intense starvation can't really eat a lot of food right away. They have to let their body acclimate towards digesting food once again.
So I came up with a little interesting fun fact for this discussion while we were both doing a little bit of research, and that is that some animals will just survive the cold of winter by basically turning into ice cubes, or the like animal version of ice cubes, and then just thaw in the spring. And like, so it's not even about hibernating and just sleeping for a long period of time. They like literally just freeze.
Yeah, it's wild. There's the Arctic ground squirrel can drop its temperature like that and kind of become a squirrel popsicle for a few months and before it revives itself when it thaws out in the spring. And there's some animals that don't fully hibernate, but they kind of go into mini hibernation states. The common porwheel, which is a bird that can enter into a torpor state for days at a time when food is really scarce or it's really cold. And chipmunks kind of do this in their underground burrows as well, essentially sleeping and snacking away the winter. While it's really cold, they've burrowed down below the frost line, and their burrows kind of go down underground, but then turn up. So when they're in the burrow area, the warm heat is rising and just staying in their burrow instead of going down and out through their tunnels and stuff. So they essentially just wait it out. And that's why you see chipmunks like gathering food all summer long. They're filling up their burrow, preparing for the wintertime.
All right. So we all know that bears hibernate. You've touched on a couple of other species that do as well. But what are some animals that our viewers might be surprised to hear hibernate?
Yeah, so box turtles, and actually a lot of turtles, they don't really seem like hibernators, but they bury themselves in the mud and they slow their heart rate down to just a few beats per minute, and they wait out that cold weather. Bumblebees are interesting. Only the queen bumblebee survives the winter, but she does this by hibernating underground and then starts off a brand new colony in the spring with the larvae from the prior year's group. Lemurs, so for example, in Madagascar, the fat-tailed dwarf lemur, that's a fun name, fat-tailed dwarf lemur, they are the only primate known to hibernate, so it can sleep for months in tree holes when food is scarce. Snakes hibernate, often in groups where they kind of conserve their body heat in a collective of snakes, in a big group, usually underground, keeping themselves warm in dens. And sometimes on a first like warm sunny day in the spring, they'll come out, but sort of maintain that dense ball of snakiness. And you might come across a whole band of, 10 or 20 snakes somewhere that's just keeping themselves warm. It's pretty neat.
Yeah, I don't have a problem with snakes at all. I used to catch them when I was a kid just to like look at them, but I don't know that I want to see that. And you know who would really hate that experience is Indiana Jones because he doesn't
He
like
would.
snakes.
In fact, so many species hibernate that early ornithologists, before they had discovered how birds actually migrate, they had hypothesized that birds hibernated under the mud, just like turtles and frogs. And serious ornithologists thought that's where the birds went all winter when they disappeared.
Yeah, that's crazy, but I'm sorry. I've just totally derailed my own thought process. Thank you, ADHD. Is that what was going on in that Indiana Jones movie when he goes into that underground temple and there's all those snakes down there? Is that why they were under there? They were hibernating?
I don't know. I'm trying to remember. Were they in Egypt when that happened? It's not so much like a
They were
cold
they were
hibernating.
somewhere, I think, in the Middle East. I don't know, dude. We might have to research this. Oh, that would explain a lot. I always wondered why that whole temple was filled with snakes.
Don't always trust what you see in movies, folks.
Hey, you don't know. You don't know.
I don't.
The people in that movie could have been nature lovers. That could have been like a subtle signal to nature information. All right. Anyway. Okay. So to wrap this up, before I take us any deeper down the rabbit hole of hibernation, do rabbits hibernate? No.
No.
Okay. Animals wake up from hibernation in the spring because of a mixture of like environmental stuff going on, like the increasing daylight and the warming temperatures, but also what's going on with their biological clocks, their circadian rhythms, and they might have to pee, right? And they're probably hungry.
Yeah. Their fat reserves are running low.
Okay. All right. Okay. Seems clear.
Yeah, exactly. And I wonder, for those watching, have you ever spotted an animal emerging from hibernation in spring? Let us know.
Oh gosh, have you guys seen the snakes, like the clumpy snakes coming out? If you've seen that, I want to know about this in the comments. And did it freak you out? Because it would freak me out. Would it freak you out? It would freak me out.
No, I'd like to see it. Nowadays, I'd just get out my smartphone and, depending on the species, I'd probably try to get as close to it as I could and see what footage I could get of it.
And it would end up here on Hike and Hearth.
Yeah.
All right.
I do this for you. So if you enjoyed this episode, don't forget to like and subscribe for more nature discoveries every single week.
So that is all for today's episode. But before we head off on our next adventure, this is just a quick reminder from us to you that you can find Dustin's wildlife photography and links to all of our content channels on our website, hikeandhearth.com.
And we love being a part of the YouTube nature community. So keep sharing your comments and your experiences with us on nature, wildlife, and conservation. And if you're not already subscribed, be sure to join us.
Absolutely. Yeah, we love the comments and chatting with you guys. It's a lot of fun. And if you are on Substack, we did just start a newsletter, Nature Notes with Hike and Hearth, so we can expand on some of the topics we cover here on the vodcast, like the rabbit hole I might go down on what was the deal with all those snakes in Indiana Jones's temple. It's only been a couple of weeks, but subscribers are certainly ramping up. So be sure you join us over there as well. Okay, Dustin, are you ready to sign us off for the day?
I sure am. Until next time, friends, keep your eyes in the skies and your hearts in the wild.
Bye, everyone.